So today we're going to be talking about exterior angles in triangles, as well as doing a little bit of extra practice on calculating angles in a specific way. So we will look at that in just a second. It'll probably be worth having something out to take notes, but there's only going to be a couple things that I actually ask you to write down, so don't worry about it too terribly much. So like I said, we're going to look at exterior angles. But we're going to actually start with something a little bit different. We're going to start by learning how to solve for a missing angle algebraically. So right here, I have a given triangle for you. Can anybody tell me what kind of triangle this is?
I think it's a left triangle.
That is 100% accurate. It is a left triangle. No. So this is a right triangle. We have, as you can see, a right angle right here in the bottom left. This angle right here is a right angle. What's the measure of this angle?
90.
It is 90 degrees. So we have a 90-degree angle here. What are the total angles, all the angles in this triangle? What do they add up to total? It's the same for all of the triangles ever. Yeah, 180. So we know that all the angles in this triangle add up to 180, and we have our three angles. What we're going to do when we have a problem like this, because as you can see, we have x plus 10 and x minus 10, and here we want to solve for x. Now, this might not look super easy, but we're actually going to set it up the exact same way you would set it up in a normal triangle problem. So we're going to have the sum of all of our angles equals 180. So let's put in the equals 180 right here. We're going to start with the angle we know, which is 90. And we're going to add in the other two angles. So we have x plus 10. And we have plus x minus 10. So all we have here is the angles that we have on our triangle adding up to 180 degrees. Now we want to simplify this and start solving for x. So we have 90, we can get rid of the parentheses. We have 90 plus x plus 10 plus x minus 10 equals 180. And then we're going to combine our like terms. So we have a plus x and we have a plus x, that's 2x. Then we have a plus 90, a plus 10, and a minus 10. So 90 plus 10 minus 10 is just 90. So we have 2x plus 90 equals 180. Now, how would I solve this from here? What would be my first step? That is accurate, Pamela, but that is not the next step. Okay. Anybody got any ideas? How do I solve this equation? 2x plus 90 equals 180.
Divide 180 by 2.
Nope. We're going to get to that step in a second.
Yeah, subtract 90 from 180.
Yep, so we're going to subtract 90 from both sides of this equation. If we subtract 90 from here, we're left with 2x. And if we subtract 90 from here, we're left with 90. So we have 2x equals 90. And then how do we solve for the x? Oof. Divided by 2, exactly. So this leaves us with x equals 45. And then since we want to solve for each of our angles, we can say, okay, we have 45 plus 10. So this angle right here is 55 degrees. Then we have 45 minus 10. So this angle is 35 degrees. And we can check these, make sure they all add up to 180, which of course 35 plus 55 is 90. 90 plus 90 is 180. So that's how we solve for those. I feel like it might be a little bit too early to be giving you algebra problems. But I'm going to go ahead and see if you can try to solve this one. This is a little bit tougher. Can anybody tell me what kind of triangle this is just by looking at it?
That has to be scalene.
It is scalene, that's true. I'm looking for the angle-based one, though.
That's acute.
It is obtuse. So this angle is bigger than 90 degrees. So it is an obtuse triangle. So what we want to do is we want to solve this one for the letter Z. So I want to see, can anybody tell me how I would set up this equation? Or does anybody have any ideas of how to set up the equation? I'll give you a hint. It's very similar to what we did in the last one. I need like the crickets sound on my phone.
Okay, guys, we're gonna take a break, and you guys are all gonna drink 5 cups of coffee and come back, and then we can like actually do math, okay?
That sounds like it might be what
Sounds
they
good to
need.
me.
I might need 5 cups of coffee at this rate. Okay, how about this? What do the angles all add up to in this triangle?
At least 179. Maybe lower than 181.
That's probably true. Can anybody give me an actual number besides Pamela? Okay, there has to be more than 2 people in this class that can tell me what the angles in a triangle add up to. Thank you, Dane. And that's correct. Anybody else? Benito, Aiden, Carter, Brennan, Jocelyn, Phoenix, Riley, Jocelyn, Jennifer, Asa. That's literally everybody who, Lucas. I guess Miranda, you're not in the class, but. How much do all of the angles in a triangle add up to? Yeah, exactly. Now I'm starting to see some answers. Okay, it's a little bit better. Okay, yep, everybody who actually answered got it correct. It is 180 degrees. So what's my big angle here? What is the measure of my big angle? You don't have to solve for the number. You can just tell me what it's listed as here. 2z minus 5. Yep. 2z minus 5. And then we're going to add in what's the next biggest angle, or even just one of the other angles. It doesn't even have to be the next biggest.
Z plus 20.
Yep, z plus 20. That'll work. And then what about the last one? I see Pamela and Todd know what it is. Yeah, so it's z plus 5. So now we're going to combine our like terms. How many z's do we have total in this? Yep, we have 4 z's. And what do all of my numbers add up to? So I have a negative 5, I have a positive 20, and I have a positive 5. Yep, they add up to 20. So we end up with 4z plus 20 equals 180. And then much like this other equation, all we have to do now is solve it for z. So we subtract 20 from both sides, gives us 4z equals 160. Divide by 4, and we're left with z equals 40. Now, as it turns out, this is actually a really poorly drawn triangle because our angles do not add up to the right things to make it look like this. So this one would be 2 times 40 minus 5. So this is a 75-degree angle. This one is 40 plus 20. So this is a 60-degree angle. And this one is a 45-degree angle. Now, obviously, these are not drawn to scale because this is definitely not a 75-degree angle here. But we can solve it algebraically. And in general, in math, if you have letters or numbers showing angle measures, those are more accurate than the actual drawing is. And that's just because a lot of times math textbooks and things like to confuse kids and give them angles that look wrong. So yes, it is supposed to be an acute triangle, but it was drawn as an obtuse angle or triangle. Okay, so that's how to solve equations algebraically. If you do the IXL or the math space, you'll have a couple of problems like this. So if you don't understand how to do this, that is something you'll want to stick around and get help with after class today. Although lately we haven't been having a lot of people sticking around after class. Speaking of which, some of you will notice that I reassigned systems of equations quiz to anybody who has not taken it or who failed it the first time. So please make sure if you have that assigned that you get it done before Friday. All right, now let's move on. We're going to look at exterior angles. And this is where you might want to start taking some actual notes. So first of all, if we extend the lines of a triangle past the edges, we can form some new angles called exterior angles. We've already talked about interior angles. Hopefully all of you know at this point that the interior angles of a triangle add up to 180 degrees. So now we're going to look at the exterior angles. So as you can see, I extended some of these lines. And the new angles we're talking about are this angle here, and this angle here. These exterior angles have some special properties, and we're going to look at those on the next page. But let's go ahead and I have a couple questions. First of all, what is the relationship between this exterior angle right here and this 90-degree angle right here? Are they vertical, complementary, supplementary? Those are the only options. Correct, Dane. So these are supplementary angles. They form a straight line. That means they add up to 180, or this one is going to be 90 as well. What about this angle right here and the 60-degree angle? Yep, they're also supplementary. Who just came in as CL Math so I can mark you for attendance? Oh, I guess they decided to leave. Well, that's Jay. Okay, that's weird. All right, so yeah, these are also supplementary, which means they add up to 180, or this one is 120. And then what about this angle right here and the 30-degree angle? Yep, also supplementary. So this one would then be 150 degrees. So that's one of the special properties. Now there's something called the exterior angle theorem, and this is something that you'll probably want to write down. And this says that the exterior angle on a triangle is equal to the sum of the two opposite interior angles. Now, that's a lot of fancy words. Let me show you what that actually means. So here's a triangle right here. I'm going to draw the exterior angles on it. So let's say this angle, and this angle. So what that means is this angle here that I just outlined, so I'll call it A, is equal to angles B and C combined. So see how these are opposite? The angle A is right here, or A's interior angle, I guess, is right here. So these are the two opposite angles. So C plus B equals A in this case. That's what this is telling us here. And this makes sense, right? All of the interior angles of a triangle have to add up to 180 degrees, and supplementary angles add up to 180 degrees. So if we have, like, let's say a D here, then we know that C plus B plus D equals 180. And since these are supplementary, we also know that A plus D equals 180. So that means that A must be the same as B plus C. The other thing that you want to know from the exterior angle theorem is that all the exterior angles in a triangle will add up to 360 degrees. So this is different than the interior angles, which always add up to 180. And the reason for this is actually pretty simple as well. If we think about it, all of these combined angles, so if we look at like this angle here, this big one, and then this big one, and then this big one, each of these is 180 degrees, which totals 540. And then if we subtract the interior angles, those all add up to 180. So we subtract 180 from that, and we're left with 360. So that's the reason behind those two things. Any questions about the exterior angle theorem? We'll look at how to use it on the next page, but if you have any questions right now, this would be a good time to ask. Okay. If you come up with questions tomorrow when you're more awake, let me know. But all right, let's move on. Let's try some practices. So we want to find the missing angles in this triangle here. We're going to have to use both the exterior angle theorem and some of our knowledge of supplementary angles. So first of all, let's look at D. We can solve D pretty easily. D is supplementary to 160, so what must the measure of D be? Or how can we solve for D? That is correct, Pamela. Good, Dane. Brennan, that is also correct. So since D is supplementary to this 160-degree angle, we know they add up to 180 degrees total. So we can do 180 minus 160, which equals 20. So we know that this is going to be a 20-degree angle. We could do the same for C. So we can say 180 minus 70, that's 110. And then to solve A, we can use the second part of the exterior angle theorem. So we can either add together D and C, which we know are 20 and 110, or we can make sure that all the exterior angles add up to 360 degrees. So if we do the 360 degrees, we have a 160-degree angle, 160. We have a 70-degree angle, and then we have angle A. All of these equal 360 degrees. So we can just subtract. So A equals 360 minus 160 minus 70. 360 minus 160 is 200. 200 minus 70 is 130 degrees. So A is 130. We could have used the other part of the exterior angle theorem to say it's equal to the sum of the opposite angles, which would be D and C here, which is 20 plus 110, which also equals 130. And then for B, we can either solve this by taking all the interior angles of a triangle, add up to 180, or we can use the supplementary angle here. Either way, you're going to get 50 degrees for B. Okay? So that's how we solve for all of those. Now we're going to actually have you guys try it. So this triangle right here, you're only given one angle, and you need to solve for A, B, C, D, and E. Before we get started, really quickly, what type of triangle is this? Can anybody tell me? It's got a special name that's impossible to spell. It is probably an acute triangle. It's not scalene, but it is isosceles. So we have two congruent sides. Remember, these tick marks means that these side lengths are the same. Since we have these two congruent sides, this is an isosceles triangle, which means that the measure of angle B is going to be the same as the measure of angle C. So go ahead, see if you can start solving for these. A should be pretty easy. B and C are going to be a little harder, and then D and E are going to be difficult as well. Good on all of them, Pamela. Nice job. Good, Dane. Good, Todd. Good, Asa. Good on all of them, Jennifer. Todd, you want to double check? Good, Dane. Correct as well, Dane. Okay, so if we look at A, what is the relationship between A and this 140-degree angle? Those of you that haven't answered so far, so are apparently stuck. That's correct, Asa. So let's see. What is that? That would be Lucas, Benito, Aiden, Carter, Brennan, Jocelyn, Phoenix, Riley, Jennifer. What's the relationship? Oh, wait, no, sorry, not Jennifer. I think Jennifer answered already. Sorry, ignore me, Jennifer. Everybody else, though. What's the relationship between A and this 140-degree angle? Asa, that is correct. Wow, you guys are really asleep today. So A and the 140-degree angle are supplementary. They form a straight line together. So since they're supplementary, that means their angles add up to 180 degrees. So what would A have to be? (180 minus 140) give us 40 degrees for A. So A is 40 degrees. Now, if A is 40 degrees, that means that B and C must add up to 140 degrees. And we know that B and C are the same because this is an isosceles triangle and their opposite edges are congruent. So because of that, both B and C are going to be equal to 140 divided by 2, which is 70 degrees. So B is 70 degrees and C is 70 degrees. Now for D and E, we can use we can use the exterior angle theorem and add these together, or we can use the fact that they're supplementary to B and C. But either way, let's say that we use B is 70, C is 70, and A is 40. So for E, we could add up the measures of A and B, so 40 plus 70, which equals 110. Or for D, we can just say this is supplementary to B, which is 70, so D equals 180 minus 70, which is also 110. So that is, once again, how you solve for all of those. Okay, let's try this last one. This is a little bit tougher. So all you need to do here is solve for x. You don't need to solve for all the different angles, although technically you could. But the way we're going to do this is very similar to the problems that we started at the beginning. So I'm going to give you a minute to try this on your own. Those of you that are not participating, I might have to keep you around until you work through it, but I'll go over it in just a little bit, and then we'll be done for today. Once you finish this up, I guess once we finish class, there is a new assignment for today. It is either the math-based task interior angles, triangles, interior angles, and exterior angles, or IXL 09 and 012. It's a little bit too big, Todd. Close, but not quite. For Aiden and Dane, you both said the same thing. Are you just guessing? Oh. Okay, so let's think about how to set this one up first. What does the exterior angles theorem say? You're probably going to have to talk through this one. What do we know about this angle, the x plus 50, versus the x and the x minus 20? Jenny, that's correct. Do we need to go back to it? So let's see. The exterior angle on a triangle is equal to the sum of the two opposite interior angles. So x plus 50, that's this exterior angle here, equals the sum of these two angles. So x plus x minus 20. We can simplify this. X plus 50 equals 2x minus 20. And then we want to solve for x. So to do this, we add 20 to both sides. That'll give us x plus 70 equals 2x. Then we subtract x from both sides. And that leaves us with x equals 70. That means that the measure of this angle is 120 degrees. This angle is 70 degrees, and this angle is 50 degrees. That is very true, Jenny. So we have one more one. Try this out. If you can solve this, then you're good to go. Otherwise, it'll take a few minutes before I start going through it because I want you guys to actually try it. So please give this a shot. If you don't know where to start, then let me know where you're getting confused. So I need to see a message from every single person before you're going to be allowed to leave. Yep, good, Todd. So now solve it. That is correct, Asa. Good work. Yes, Asa, that was correct. Did you just guess? Oh. Good, Pamela. Correct, Dane, although it's not X. Not quite, Carter. What if you just don't what? There you go, Dane. Oh. That actually is really smart, Asa. I didn't even think about that. Okay. Nope, it's not 0. That is correct, Jennifer. There's a Jennifer and with Jenny here. There's Jennifer and Jenny, and you both have the same
Oh
initials.
no, the Jennies are taking over.
It's
That's
true.
right.
Not quite, Carter.
We need to go to the non-Jenny bunker, guys.
Well, do you remember that time when the math teacher decided to change everyone's name to a different version of Asa?
The Asa massacre of 2020.
That was funny.
There still wasn't.
Like
an
literally
Asa.
everyone in the class was named Asa for some reason.
That's true. That was a good time. Okay, so what we have to do is once again set this up using the exterior angle theorem. So we're saying the exterior angle, which in this case is z plus 30, is equal to the sum of the two opposite angles. So we have z minus 10 plus z minus 20. Z, we have a positive z and a positive z, so we can combine those to 2z. And then we've got minus 10 and minus 20, which gives us minus 30. So we have z plus 30 equals 2z minus 30. So we're going to add 30 to both sides. That's going to give us z plus 60 equals 2z. Then we subtract z, and we're left with z equals 60. Now, one of you came up with a very intelligent strategy that I hadn't noticed. This is a right angle, which means this has to be a right angle, so this has to add up to 90 degrees. So you could have just solved for it that way too. But I have to be honest, I didn't catch that one. That would have made this one a lot easier, but hey, if you see something like that on the homework, go for it. So like I said, your homework today is either the math-based task triangles, interior angles, and exterior angles, or you could do IXL 09 and 012. The IXLs are pretty short, that's why there's 2 of them. If you have questions or if you need help, please stick around, but otherwise you guys are good to go. Have a good rest of your day, and I will see you tomorrow.